to solve Cambridge IGCSE physics paper, that is a theory paper, and the code for this paper is 0625/42. This is a mature paper 2023. Let's start off with question number 1, and it says that figure 1.1 shows a helicopter which is stationary at a height of 1500 meters above the ground. So state two condition necessary for the helicopter to remain in equilibrium. So first thing is this: no resultant force or sum of all the forces acting on the object must be equals to 0. Second thing is that you need to have no moments, no turning effects, no torque, no moments, no turning effects. The turning effects. So these are two conditions required for the object to be in equilibrium. The mass of the helicopter is this. Calculate the change in gravitational potential energy of the helicopter as it rises up from the ground. So we need to find out the gravitational potential energy. The formula is GPE equals to mgh. M is the mass, 3200 times 9.8, which is given in your instruction page number on page number 1. And then it's going to be h is height is 1500, so you will end up with 47 or 4.7 into 10 to the power 7 joules, or you can write it down 47 megajoules. Okay, it's up to you how you do this thing, but it should be in to a significant figure. Figure 1.2 shows the vertical speed time graph for a parachute who jumps from a stationary hot air balloon. Okay, the parachute jumps from the balloon at a time equals to 0 and reaches to the ground at point B. The point A indicates when the parachute opens. On figure 1.2, label a point on the graph where the acceleration is 0 with 1. Okay, for where the acceleration is 0, we have to measure that thing as 1. And okay, there is this point as well, because on the straight line the in a gradient of speed time graph is going to be acceleration, so it's going to be 0 on a straight line, negative with 2, so negative is going to be 2, and decreasing with 3, so this is going to be your 3. Okay, explain in terms of forces the change in motion which occurs when parachute leaves the hot air balloons until point A. So initially there is acceleration due to the weight for this object, and there will be unbalanced forces acting on this object. So obviously there will be resultant forces and downward force. And there are a few other things that you need to understand when the air resistance increases as speed increases. So when air resistance increases, so obviously resultant force is going to decrease, and acceleration is also decreased at that time. So again, the concept of terminal velocity will come. When the air resistance is equals to the weight, there will be a constant speed. A student catches the ball. The speed of the ball immediately before it is caught is this is the velocity. The mass is this. You need to convert into kg. Calculate the kinetic energy. Is mv? Oh, sorry, is mv square. So 1/2 m is what? 160 divided by 1000, and velocity is 18 square. So this is going to be 26 joules. So this is your final answer. It takes 0.12 seconds to catch the ball and bring to rest. Calculate the average force. So this is, I'm going to use the formula for impulse. So we need to find out the force, mv over t. M is your mass, that is 160 divided by 1000 into 18 divided by time is 0.12. So it's going to be 24 newtons. So this is your answer. As the student catches the ball, she moves her hand backwards. Explain the effect of this action on the student's hand. So obviously there will be a longer time of contact. This can be explained as smaller force will be acting on the a smaller force will be acting will be acting and acting, and it's not going to be does not hurt as well. Figure the 3.1 shows a person moving across an ice-covered pond to reach a ball on the ice. Explain why this way of moving across the ice is safer than walking. Use your understanding of pressure in your answer. So obviously when he's lying, the surface area of that person is going to be increased and the pressure will be decreased at this moment. And pressure will be decreased on ice, and we know that the pressure is inversely proportional to area, and obviously the pressure is going to decrease in this scenario. Okay, figure 3.2 shows a side view of the pond in with a layer of ice floating freely on the water. The surface area of the pond is this, the mass of the ice is this, the density. Calculate the pressure at point x. Okay, so first of all, pressure in liquids is equals to rho gh. Rho is the density of the water, which is going to be 1000 times 9.8. Then the height is what? Height is 0.45 meters. So when you do this, this will end up 14410. Now you have to do you have to find out the weight of the what you have to find out the weight of the ice. Okay, so the weight of the ice is what? Is mass into g, with 690 times 9.8. So this is going to be 1352.4 newtons. So now you have to add this thing to find out the total pressure. So it's going to be what? 4410 plus 1352.4. So it's going to be the required value. Let me do the calculations. So you will get this final value over here. Okay, moving to the next question. The temperature of a fixed mass of a gas at a constant volume is decreased. State and explain in terms of particles how pressure of the gas changes. So obviously the pressure is going to decrease, velocity is going to decrease. Um, Velocity is also going to decrease, then there will be the less kinetic energy. Obviously that will result in momentum, less momentum that would be, and then collisions will be less because they have less kinetic energy, less velocity, the momentum is less, so there will be less force exerted on the walls of the container, and there will be less impulse change as well. So you can write any of these answers. State the value, absolute value 0 in Celsius. So for that is basically 273 degrees Celsius, because if you do that thing in Kelvin, so it's going to be like this. Explain what is meant by the term absolute zero. Refer to the particles in your answer. So it's going to be the temperature at which particles have least kinetic energy. Least kinetic energy. So this means that it has the lowest temperature as well. Lowest temperature of the molecule. So you need to memorize this value in order to understand this thing. So basically this is the temperature at which the kinetic energy of the particles is going to be less. Okay, cylinder 1 contains P1 is going to be 350 centimeter cube of gas at a pressure. Okay, this is volume 1, I'm sorry. P2 P1 is going to be 9 into 10 to the power 4 Pascal. The gas is transferred in the cylinder 2. The pressure of the gas is increased by this, and you need to find out the volume. Okay, you need to find out the volume. So we know that P1 V1 equals to P2 V2. So this is going to be V2 is going to be P1 V1 over P2 equals to V2. So P1 is going to be what? 9 into 10 to the power 4 into 350 divided by 1.6 into 10 to the power 5. This is going to be 196.875. So we will do this to 200 centimeter cube. Figure 5.1 shows an electric heater used to heat a room. The dimension of the room is this, the density is this. Show that the mass of this. Okay, so we know that the density is equals to mass over volume. So again, if you do make it the m subject, so it's going to be rho times v. So density is what, 1.2, and volume is what, 4.5 times 6.1 times 2.4. So it's going to be 79 kg. So this is what we need to prove. Okay, the power of the heater is 1100 watts. The specific heat capacity of air is this, and calculate the time taken to increase the temperature of the air in the room from 1600 degrees Celsius. Okay, first of all, what you need to do is you have to find out E is equals to mc delta theta. So for this, mass is what, 79, and the specific heat capacity of the water is 1000. Then change in temperature is 4. You can subtract 20 minus 16. So this will give you 316,000 joules. Now we have to find out the time. So power is equals to energy over time. So we will cross multiply. So time is equals to energy over power. So energy is 316,000 divided by power. Power is 1100 watts. Is going to be 287.27, which is approximately 290 seconds. So this is how you do this question. Okay, moving to the next question. Suggest one reason why the time calculated in A2 is minimum time needed to increase the temperature of air in the room from 60 to this. Basically, the thermal energy is transferred to the surrounding. Thermal energy is transferred to surroundings. It can be furnitures, it can be walls, objects, etc. Okay, figure 5.2 shows cross section of the double glazed window in the room. This outer glass pane, narrow air gaps in a glass pane. State the main method of thermal energy transfer from the room to outside, which reduces the type of window. So it's going to be conduction and convection. So you can write any of this method. Two types of seismic waves are P waves and S waves, and state the two types of the waves, that P waves and S can be waves. So S waves are longitudinal and they require medium to travel, so they travel parallel, travel or move parallel. Whereas the S waves are transverse wave and they travel perpendicularly. Okay, okay. The velocity of the P wave on the Earth's solid crust is 7.2 kilometers per second, and its frequency is 4.5 seconds. Calculated the wavelength of this P wave. So V is equals to F lambda. So we need to find out the lambda. So it's going to be V over F. V is what, 7.2 into 1000 divided by 4.5, and this is going to be lambda is equals to 1600 meters. So this is the final answer of this question. Next, moving on to question number 7, shows a container of oil. A ray of light shines on the surface of the oil. The refractive index of the oil is this. Draw a normal to the plane where the ray enters the oil. So if you want to draw the normal, so this is going to be your normal. Angle x is 56. The value of angle of refraction is going to be 90 minus x. So this is also 90 minus x. Okay. Calculate the value of this. Okay, so you can use sine I over sine R. So this is going to be what, sine R equals to sine I over n. Sine I is sine 56, and this is going to be, this is 56, so this is going to be 34. So sine 34 over 1.47, this is the refractive index. And if you do these things, so basically if you do this thing on the calculator, so you will get your required answer, which is 22 degrees. State then the approximate speed of light in air. This you have to remember this thing because it's going to come in your other questions as well. Okay, calculate the speed of light in oil. Give your answer to three significant figures. So for this, you know this formula: speed of light in air, speed of light in air divided by speed of light in oil. Okay, so we cross multiply with this. Speed oil is equals to speed light divided by n, which is going to be 3 into 10 to the power 8 divided by 1.47. So it's going to be 2.04 into 10 to the power 8 meter per second. So this is your final answer. Moving to the next question. State what is meant by magnetic field: region or space, region or space around which magnetic poles experiences force. Define the direction of the magnetic field, and it's going to be in the direction of force, direction of force on North Pole. So this you have to remember. Figure 8.1 shows negatively charged metal sphere and draw full lines to show the electric field. Okay, so for the negative charge, these are the lines that you need to draw to. Okay, if it, next question is this: figure 8.2 shows a circuit and the three cells are identical and have zero resistance. The resistor R1, R2, R3 are identical. The reading on the voltmeter is 6 volts. Okay, these are identicals. When the diode is conducting, it has a zero resistance and zero potential difference across. Determine the EMF across one. So there are three batteries, 1, 2, 3. So everyone has 2 volts because you have to sum. So it is saying to find out the EMF of one battery. Determine the ratio of PD across R2 and a PD potential difference across R3. So it's going to be 1:2 because R just a second, R2 ratio R3 is going to be 1:2 because R1 and R2 are in parallel, so their total resistance will decrease, or if their total resistance is X, so the resistance of R3 will be twice of that thing. All the cells are reversed, so if you do that, so the current in the circuit will be zero. Why? Because it has a diode, and diode does not let the current to flow in opposite direction in a circuit. Determine the new value of the ratio of the potential difference across R2 to the potential difference across R3. So now if the diode is working, then obviously this has full resistance and this has also full resistance, because now the circuit is a series circuit. So it's going to be 1:1. Both resistance are in series. Okay. Table 9.1 shows the properties and the value of alpha, beta, and gamma. This you need to remember this thing. So in alpha, the number of neutrons are 2. This is the charge, and it can pass through thin sheets of paper. Beta has a 0 number of protons, 0 number of neutrons, but it has a charge of minus 1.6 into 10 to the power minus 19. Gamma has a 0 number of protons, 0 number of neutrons, 0 number is charge, but it can pass through thick lead. Cannot pass through thick lead. Basically, normally it's a 6 centimeter thick. State how beta decays change the nucleus of an atom. So nucleus has one less neutron and one more proton. So this is what you need to write out whenever there is a beta decay. Okay. Radiation detector used in a laboratory detects background count rate of 30 counts per minute. A radioactive source is placed in front of a radiation detector. The initial reading on the detector is 550 grams per minute. The half-life of the source is 25 minutes. Calculate the expected reading detected after that. So first of all, you need to find out the half-life, which is going to be 3 half-lives. What is the amount of remaining uh, just a second, remaining element. So this is 550. You have to subtract the background radiation is going to be 5. Okay, the background radiation is 30, so it's going to be 520. So in 520 is half of 520 is 260, then its half is 130. This is one half life cycle, this is second, and this is third, which is going to be 60. So you have to simply reduce that thing by half. Yeah, state two safety precaution taken when moving or using storing radioactive source in a laboratory. So use lead boxes to move the radioactive element. Keep distance. Use tongs. Keep distance. Use tongs, gloves. Oh, okay, that's it. Okay. So moving to the next question, state the equation that defines the average orbital velocity v of the planet. State the meaning any symbol you use, which is going to be is equals to 2 pi r over t. R is radius and t is the time period. So orbital period you can call it as well, orbital period. Okay, this is done. Suggest why countries that are significant distance from the equator experience significant temperature variation throughout the year. So basically, rays from sun strikes the country for different number of hours per day throughout the year. So it totally depends upon the number of rays that are striking on a particular region. Fill in the gaps and in the paragraph about the star much more massive than the sun. The stage that follows the stable state in the life cycle of a star is called as red supergiant. It then explodes as a supernova to form a nebula. This leaves behind a neutron star or a black hole. Okay, a galaxy is moving away from Earth with the speed of this, and the value of Hubble constant per second is this. Calculate the distance is here. So we know that Hubble constant is v over d. So for distance, we are going to change the formula. This is going to be v over h naught, which is going to be velocity is 33,000 kilometers. So you have to convert it into this, then you have to do the Hubble constant 2 into 10 to minus 18 per second, and then you have to multiply this with a light year. So 1 light year is basically 1 light year is equals to 9.5 into 10 to the power 15 meters. Okay, so when you do the calculation, 1.6 into 10 to the power 9 light years, basically you need it in light years, so that's why you have to divide it in this. So that's it. Thank you very much. Take care. Bye bye.